All right. I just wanted to dive deep into this unit, complex numbers. So, what you see here, these are the things that subtopics that I'm gonna be talking about. So, I'm gonna be starting with sets, and then the I or J substitution conversions. That is from rectangular form to polar form and polar form to rectangular form, and then gonna be talking about the addition, the subtraction, multiplication, and division of rectangular form. So without wasting any time, let me let's look at if you remember when you go back to grade 12 and visit the chapter called sets. If you were asked to simplify without a calculator, if let's say you are given the root of 8, and then you're asked to simplify, um, simplify without using a calculator, without using a calculator, calculator. So if you had a process, a step one that you'd follow, you definitely want to look at the number 8 and try to write it in its simplest terms. What I'm trying to say is if you have, you can multiply 8 with 1, and then in order for you to get 8, and then you can also multiply 4 with 2 in order for you to get the number 8. So when you split number 8, you can simply write it in this form: 4 multiplied by 2, right? Still under the square root. So you can further split whatever that is inside the below, that is under the square root, as 2 4 multiplied by 2, right? And then when you punch the root of 4, you're going to get 2. But when you punch in your calculator the root of 2, you'll get a certain number, but it's actually a good thing to write it in this form. Leave it as it is in a set form, right? So where am I actually going with this? What if now you were required to simplify? Let's look at this. If you were given -8 and you are required to simplify without using a calculator, of course the answer that you'd get, that would be an undefined answer. But what if there's a way, if we use substitution, what if we use substitution in order to solve this? So substitution, that is to say, whenever I have myself the root of -1, then I would equate that to I or J. Negative root 1 goes to I. So it's one and the same. This is substitution. Every time you bump into negative root 1, then you use I or J. Since you are an electrical student, then it's actually best for you to use J instead of I, because you might confuse I with current. Okay. So let's see. If I were to write, I can also write negative root 8 as 4 multiplied by 2 multiplied by -1. Then I can further write it in this form, -4 2 multiplied by -1, right? So remember what I just said. Okay, we can further simplify 4, right? 2 and then 2√2. Every time you bump into a square root of -1, then you can either use I or J. So I'm just going to use J. This is the final answer for that. So let's look at one example. I have 3x x minus 6 equals to -39. So I'm going to try and multiply 3x with whatever that's inside the bracket, as it's going to give me 3x squared minus 18x minus 39. No, not 39, but yeah, minus 18 equals to 39, -39. So if I take 39 to the left hand side, then it's going to become 3x squared minus 18x minus plus 30 negative becomes positive, hence it becomes 39 equals to 0. Then you look at 3. I can divide 3. 3 can go into 3. 3 can go into 18. 3 can go into 39. So if you further divide by 3, 3, 3. So this thing is going to become x squared minus 6x plus 13 equals to 0, right? So when you look at the terms that would give you, the terms of 13 that would give you -6, there's nothing that would, if you add and subtract, is going to give you -6. So it's only, you only have one multiples of 1 and 13. So we are allowed to use the equation x is equals to minus b plus or minus the root of b squared minus 4ac, all divided by 2a. So now this is, I have a here, which is b, and then c. So x is equals to -b. I have minus 6 in this case. So negative is going to become 6. I'm just gonna put it here, negative. I'm only going to focus on the coefficients. Plus minus b, which is going to be -6 squared minus 4, and then a, in this case the coefficient of x squared is 1, and c, which is positive 13, all divided by 2, 1, right? Then negative is going to give me positive, plus minus negative 6 squared is going to give me 36. Then 4 times 1 times 13 is going to give me 52. And then leave the square root and then all divided by 2. 36 minus 52, that's going to give me 6 plus or minus the root of minus 16. 36 minus 52, that's actually minus 16, all divided by 2. So now I'm going to try and write 16. I'm going to split it, write it in its multiples. So I have 1 and 16. So 6 plus minus, here we have negative. We can write 16 as the same as 1 times 16, right? And then negative 1 here because I have minus 16 under the root. So that's going to be 16 times negative 1, all divided by 2. Okay. Now I can try and split whatever that I wrote previously in this format. I'll just create some space. So whatever that I wrote in the previous page, that's going to be 6 equals 2, it's an equal sign, and then split 16 multiplied by negative root 1, all divided by 2, right? So the square root of 16, oh, I think I made a mistake. It's supposed to be plus and minus, plus minus, plus minus, plus minus 6 plus minus the root of square root of 16, you're going to get 4. And then negative, the square root of negative 1, like we spoke before, whenever you see the square root of negative 1, you're going to substitute that with I or j, but in this case I'm going to use j, all divided by 2. So 6 divided by 2, divided by 2, you're going to get 3 plus minus 4 divided by 2, that's 2j. So this is the final answer. So I want you to highlight this. This is what we call a rectangular form. The whole 3 plus minus 2j. This is what we call a rectangular form. Rectangular form. The name that we are going to assign for this whole thing is what we call a rectangular form. But 3 on its own, or this first digit, this is what we call a real number. Real number. And then the second digit, 2 and j, that's what we call an imaginary number. Imaginary number. So this is the introduction of complex numbers. We just explained what a rectangular form consists of. It consists of of imaginary number and a real number, and then the whole combination is called a rectangular form. And then we also did one example. So let's look at a second example. Let's say now you have yourself number 2 here. Let's say now you have x plus 7 over x equals to -5. So the best thing to solve this problem, remember now, I don't want x to be the denominator, so I have to get rid of x as the denominator, and then the best thing to do is to multiply the left hand side with x and the right hand side with x. So that is to say, if I multiply x throughout, I'm going to have x plus 7 over x equals to -5 multiplied by x. So x and x, if I break down the brackets, I'm going to have x squared, and then x and x will cancel, and I'll be remaining with 7 equals to -5x. Now whatever that's on the right hand side, I'm gonna move that to the left hand side, which is going to be x squared plus 5x plus 7 equals to 0. So if I'm going to solve for x, there's no way that I'm going to get factors of 7 that would give me 5 if I add them. It's no way. So this thing, it's undefined. We might say it's undefined, but we can still use this equation. X is equals to minus b plus or minus the root of b squared minus 4ac, all divided by 2a, right? So negative, remember that negative goes in hand with the coefficient that's next to x, and then that's going to be -5 plus or minus the root of b squared, which is going to be 5 squared, minus 4 times a, which is the coefficient of x squared, which is 1, multiplied by c, which is 7, all divided by 2 times a, coefficient is 1. So let's try to break down whatever that's inside the bracket. 5 squared is going to give you 25, minus 4 times 1 times 7, that's going to give you 28, all divided by 2, all divided by 2, and then 25 minus 5 plus minus 25 minus 28, then you're going to get the answer of -3. -3 all divided by 2. So let's try to write whatever that's under. If you were to write 3, -3 can be written in a form of 1 multiplied by 3 multiplied by -1. So that is to say it's -5 plus minus whatever that's inside can be written in a form of -1 times 3, all divided by 2. So -5 over 2, okay, plus minus. Remember that once you see, let me just try to split this first, -1 times the root of 3, okay, and then every time you see -1, you're going to substitute that, so it's going to be -5 over 2 plus or minus j. Remember, if you substitute -1 with j, and then the root of what, of 3, all divided by 2. So this is the answer that this is the final answer. It's still in a rectangular form. The whole thing, you have this real number, and you also have the imaginary number, but then the whole thing is called the rectangular form. So that's that with regards to the first 2 bullets, that is sets and I or j substitution.